Which one? TWC?
TechFios. There is a network called TechFios. Italian.
Is it also the same network?
Internet, yes. Wi-Fi password. Internet key. Yes.
Yeah.
And then, can you write down the network name too?
I'm sorry?
Network name.
Internet.
Are they connecting to 5G?
Either one, doesn't matter. 5G or ports.
Subject. This is
Class. So now go over the and then three on 880. 4439.
Excuse me. Thank you. Okay. Everyone should have this phone number saved by now. If you guys need anything, you can always reach out to me, Shajat, me, AP, or Enrico, but I just put two of our phone number. If you're not in WhatsApp right now, then contact Shajat or me so we can put you in the WhatsApp group. It's very important because we make important announcements there. Okay, so our topic for today is actually Computer Network System Specialist, CNSS. But before we do that, we're just going to quickly glance over the orientation, those who missed it, and just a review for the people who were here. So this is a QA and BA training program. And it says winter 2018. That's good. So our agenda was about us. We played a little bit game. Why IT? Quality assurance. What is quality assurance? What is called business analyst? Why TechFios? Our leadership. Goals for you. Training environment and curriculum. So I'm going to quickly go over this because we already went over it twice. So about us, like it says, is that we are an IT company and we train QAs and BAs. We have other trainings as well, but for now we have QA and BA available. We are based in US, of course. Texas is our only class that is in class. Everywhere else is remote. So we do have mentoring available in the following state that you see, but there's no actual classes. Texas was actually our first class since IT was growing here. So we decided to open up here. Live remote training program. That just means that, you know how we're training over here, we can do the same thing. We're going to do the same thing remotely. So if you're ever unable to come to class, we can do the mentoring over the internet. Then we played a little bit game, the imitation game, and that was business analyst, developer, and QA, and how they all fit in together. So the business analyst basically writes the requirements for us. The developers develops it, and the QA checks it. In simple words. Why IT? As you know, if you can see the map right there, Texas is very dark. There's a lot of IT company that's opening up here. And the growth is going on top of the roof, and there's a lot of STEM jobs available. This is kind of an interesting picture. Out of four person in here, unemployed people, the you can see the black and gray, that's where it cuts off. That's the STEM position that's available. The black is the STEM position. The other ones is others. So 1.9 to 1. So that's a lot of STEM positions. That's science, basically science, math, technology, engineering. So we actually talked about this a little bit, but if you want to not look at numbers, but if you want to talk people, then out of the 10 richest men in the world, 6 of them are in the IT industry. And as we all know, Bill Gates, Microsoft. Then we have Jeff Bezos, I can never say his name, Amazon.com. And we have, of course, Facebook, Mark Zuckerberg. There is 6 of them actually out of 10. I believe the Google is of course on there, Larry, and then I can't remember, but 6 of them. And then if we talk numbers, if you see the computer occupation that's in the very top, it's really high. Compared to other STEM jobs. So we are talking just science, technology, engineering, math. This is it's really high. And then the happiest jobs in America in 2013, QA was number 2, and it's still in the top 10 range in 2017. So that's really good. Not only you're going to be making the money, but you're also going to be happy doing it. So that's that. Then I have a little snapshot right here from a newspaper. Software QA engineer jobs are on a healthy growing track with an estimate of hundreds of new jobs, 1,000 million new jobs positions set created by 2022. That's higher growth rate than anticipated, skill jobs. And so basically what they're saying that this chart that you're seeing, if you basically, it's kind of interesting because if you basically flip that chart backward and you compare software QA and let's say that we put development in there as well, and then we look at everything else, not just STEM jobs, just everything else, software QA engineers is going to be as high compared to other ones. There was actually another newspaper article that's here. I don't know what happened to it, but is there. Software quality assurance. That's what most of you guys will be doing, maintaining quality of the software. So we build cell phones, computers, let's say Tesla cars, and we have softwares in it. The developers are building softwares every day. But someone needs to check that software. How do you know if I don't press the start button or the AC button in a Tesla and it's going to take me like off-road or something? So that's why we're there to check, making user errors to make sure the product quality is good. Auditing, testing, identify weakness in process, reporting those weaknesses. And we're going to, as we go on in class, we're going to learn more about that. So yeah, you're going to be checking a software, for example, maybe this remote, but you have to report it, and we're going to learn about those reporting. You have to do a little bit of auditing. We're going to do that. What are the weaknesses of this remote itself? Maybe the buttons are not working correctly. That's a weakness. We need to write those down so that our stakeholders can see it. Report those weaknesses to continually improve process. So that's what software quality assurance basically is. And then you have, did I skip one? Okay. Then you have the salary and demand of a QA. Growing market, salary could be 80 to 120K, mid-level to senior. Center of action has a high growth field. A job of patience. A lot of us don't have patience, but we still make it through. And I'm talking about me here. But prevents defect may lead to financial loss and negative reputation. So I think the last time we used Samsung as an example, I'm not real quite sure, but see, if something happens to, like, if the battery goes off in one of your Samsung phone, that's a bad reputation for Samsung. They are a multi-billion-dollar industry right now, but that one thing, one blow up of the cell phone is going to lead to a very negative reputation, right? No one wants to, no one wants to buy it. They're gonna go with Apple or Android, different Android. So we don't want that negative reputation. That's why we have QAs there, and that's why it's never gonna go away. Why do we need QA? Bugs everywhere. That bugs, the term, AP was talking about it last time. It actually came from whenever there was two guys sitting in a basement, or I believe that was the story, and they're both using computers, and some reason one of the computers stopped working, and they were trying to figure out why, and it's because there was a bug in one of the hardware, and that's where that terms actually came from. Now in the industry, we use it for different reason. Whenever we have a software crash on our cell phone, or maybe we cannot make a phone call or take a picture or something like that, we call it a bug, basically, like there's something wrong with it. So that's the history of bugs, I guess. Importance of QA. I'm not going to go over this, but as you guys can see, there's the military, or actually I don't have the military on here, but a software configuration caused a plane crash. And then the second picture, I have NASA confused because the software calculation was incorrect. That's why it was orbiting around. And then I have Nissan that was recalled, and that's because their airbag was malfunctioning. And then we have the Northeast blackout, then software security flaws revealed in OLA mobile, and we have overexposure of radiation, which I think is one of the top one. Even in the medical industry, we don't think software for some reason. But whenever you are going through that X-ray, or whenever the doctor is giving you a report, or whenever you're doing MRI, hopefully you guys don't have to do that stuff, but whenever we are going through that, that's all software based, and we need to make sure as QAs that those softwares are working correctly, so our patients are not getting treated wrong because of a software glitch. Then I think we skipped BA. I'm not sure. Let's see. No, we're good. Okay. Business analyst. Okay. So business analyst is a little bit different. So QA is more technical. They are part of development team. Business analyst is more part of the business team. Simplest way to explain business analyst, they are a translator between the business side to the technology, the development side, okay? So basically, I'm going to say, as a customer, I might say that, oh, I want a black screen, red ink and stuff like that. Well, the business analyst is going to go in there and try to understand that and say that, oh, maybe we're not able to do red screen, black screen together or something like that. And I actually have a video for that I'm going to share with you guys later. But their job is to translate the requirements to the developers and of course the QA, so they can build the softwares and test it. So that's business analyst. Why TechFios? Let's see, we have leadership experiences over here. My name is Rihanna. I'm a senior quality assurance engineer. We have Enrico, who's teaching in the other class. You guys can probably hear him. He's very loud. He's high-end company. He works in actually Pennsylvania currently. He was here last week. We have AP who works in IBM Watson Health. That's over in Farmers Branch. He's also a senior Scrum QA. And then we have Shaz, who is right there, and he is working in airline industry right now. And then it gives us our leadership experiences right there. Goals for you, our goals for you. We're a little different, and we kind of take pride in that, because we did not just create this curriculum out of thin air. It took us a lot of time to actually make this curriculum. We want to make sure that when you go to the job market, you don't just go for one job. So you don't go for only Oracle expert or Oracle QA expert or Microsoft QA expert or just Selenium QA expert. We want to make sure we train you in all the areas so you can eventually grow further in your career.
Can I ask you a question? So you guys don't train on Python?
No. No, we don't Python because there's not much QA that's been done. But Selenium, we are using Java, which most the industry use Java for it. But Selenium does have Python option. Yeah, but we do Selenium Java instead of Selenium. So we want to train you in all areas. So whenever you go to the job market, you are not limited to Oracle or HP or UFT or Selenium or SOPUI or the web API testing. You have knowledge in all areas, so you have an open market, right? It's kind of like selling a house. Whenever you're selling a house, you want to make sure that you display all the features that you want, and whenever you're buying it, you want all these features in it, right? You just don't buy it because you think the price is good sometimes, but we still look through all that. So kind of think of it like that. They're going to look at your resume and they're going to see that you know all this stuff, which you will. And that's our goal for you. And eventually you can become a lead, and that's the plan. Training environment, real life job scenario, hands-on training. So as we are going through the class today, you guys will probably get a little demo of what our hands-on training are. Live training, online training, module presentation every month. Sorry, I have a little cold, so I'm homework and project exercise based on real life job scenarios, interview training based on current job market, and job support. So the homework part, I just want to mention, you are not going to be actually submitting it to me for grading. You're going to be submitting it to me just for checking. And also, we are also checking if we're not going to go one by one to check. If you have any specific questions, then we're going to, of course, but then we want to see you are actually taking this class seriously. So you're actually doing the homeworks and stuff. TechFios curriculum. This is very high level. Basic computer and networking. That's what we're going to do today. SDLC, Scrum Agile, manual testing, SQL and database, QTP, Selenium, interview preparation, and diagram. And I think later on this slide we have more of a in-depth, little in-depth curriculum. So we are right now, as of today, we are in tech savvy mode. So we are going to be learning about not everything today, but because you can see it's week 1 to 3. We're going to be learning about a lot of this today, and hopefully by what's today, January, by mid-February, you know how to create your own website. And it's really simple. So this is our roadmap. If anyone wants to see, if anyone wants me to email this roadmap, just text it on the group and I'll go ahead and email it. Course requirements, laptop, desktop, that's a mandatory. because as we're doing things here, it's not mandatory right now. After a few weeks, it will be mandatory because we're going to be using softwares that's going to be in your computer, and you want to practice and follow along with us. Internet connections, those of you who are here don't have to worry about that. TechFios is okay. Those of you who are on the internet, on the GoToMeeting, you guys have to have good internet connection, phone, and dedicated time. Then it talks about job qualification. And then here we are. Can you spot the difference? That game we played. So that was a quick introduction. And I did it really fast because I didn't want to bore those of you who already went through this once and or maybe sometimes twice. So we're gonna go to our lesson quickly. But before that, do you guys have any questions?
Well, it's good. You give a very high-level overview. That's
Right.
true. But I'm talking about as far as the company's real-life scenario. Because I'm coming from the industry with 17, 18 years of my experience. Basically, most of my activities was manually testing, and at the end of the day, also manually automated as well. So when you see the business analyst when you go through, I was expecting a little bit more term from you because see, when you have a specification comes to your desk and you see that your business analyst did not do a proper job, he did not really, articulate all the features and everything. As a quality assurance point of view, when you see most of the, if you don't understand the whole features and everything, how you come up with the test plan in the first place? So well, how you are going to do, what is your steps? My question to you, since you are quality assurance engineers, so what steps and how you are going to make up the point that you are going to understand who are you, who are going to point of contact, and how you are going to go through situation?
Well, if it is a one-time thing, I believe I'll just talk to the business analyst myself. But if it's an ongoing thing, then I probably have to get my project manager involved in it. Because if I don't understand the requirement, if he's not writing the requirement clearly, then it's not only hurting me, my job, it's already hurting everyone in the teams, right? Because we're not creating effective product end of the day. So product owner has to be involved. If not product owner, then probably senior manager. Yeah, that's what I do. And those tactics, as we go along, we will even give you scenarios too. Like you gave me a scenario, we'll give you scenarios too. And we'll kind of talk about it. Things that we have went through, things that our student has went through. We'll go and tell you how we dealt with it in the past.
Second one is like a Selenium is open source. You can only do, install everything from there.
Right.
So it's basically the tool that when you are going to do, using the Java to automate. But what I can expect from you, that what you can give me exposure in that particular, that what kind of support I can expect from you. As far as Selenium? As far as the, automation, the feature is concerned.
So are you talking about just automation, right?
Yeah, I'm talking about the Selenium part and the Java, and you're going to have that kind of scenario.
Okay.
Within the 14 weeks of that particular comes in, right?
Okay.
After the manual testing is gonna, whenever go through, then it's come through the. You're also going to do the automation of the Java as well, right? By using Selenium tools.
Yeah, we're using Selenium.
So what kind of support and what kind of project and what kind of things you're gonna do that as a quality assurance engineer that I will expect from you to make sure that I'm ready when I will be facing an interview or a job market.
So first our curriculum, the way it goes, we just teach you about Java. We don't even touch Selenium. And then we introduce you to Selenium and Java, okay? Because a lot of the people here and a lot of, even me, don't have extreme Java experience, right? But even though we were using basic Java. So after learning that basic Java, we introduce Selenium, and then we teach you how to go through websites. You know, for example, go to Google, search something, and then give me the search number. So those kind of things. Probably in real life, you're not going to be searching through Google unless you work for Google. But Let's say that you have a website that your developer is developing. Then you're going to go in the website and say that, okay, well, click here, click image, click this, see what happens, go to YouTube or Google Plus, and we show you basically how to do that with Java in Selenium.
Yeah, but in the job market, are you really working in the job scenario? I mean, in this case, can pay you $100,000 per year. It's just like a high school graduate can able to do this work. I mean, what you can able to make sure that whenever you are working with a troubleshoot scenario, and make sure basically when you are working with the, I mean, any kind of website applications, basically finding the where is the basically things is not working right by doing the CSS, all kind of stuff and all kind of right, and there's the Selenium tools and the Java application come into play. So from that perspective, what kind of material that you have trained, make sure the people who are, I mean, taking your class like me and other people, make sure that I have that kind of exposure to troubleshoot their scenario.
So yeah, you're right. The one I showed you is very basic, but we are going to go along with the class and then show you a little bit more. But as far as troubleshooting goes, you have to understand automation is not always done unless it's a regulatory thing. So what's the point of wasting time and making a script for a computer to go in and do this? I'm going to fill out a form. And I'm going to only test this once to find bugs, right? What's the point of me writing a script and wasting my time to test this just once? High level, as far as high level goes, let's say that we are using this form every day. Then I'm gonna probably want to see, I don't know, 10 or 20 times where I'm going to click the submit request. And then after I hit the submit request, maybe I'm going to log in the student portal, like in the back scene, and trying to get that number and retrieve those information. And I'm going to check if it's going in correctly. And now that's the automation you're going to be learning.
So who decides which part needs to be automated and which part needs to be?
You will decide.
Oh, the
yeah.
QA, okay.
Yeah. So after you learn manual testing, and then after you learn, automation, you will know when to do it. And of course, we will show you the scenarios as well. Does that answer your question?
No, fine, but I'm talking about the long-term point of view. I mean, once the manual testing, your job is finished, completed. I mean, you need to, maintain your software for years and years to come. And you might have a 2,000, 3,000 test cases to work with. I'm not going to hire someone to come and do that, get the job done for a month. I need to 1 week.
You don't think...
So as a tester point of view, you need to have the, kind of sort of that expertise to make sure that all the features and everything working on my fingertips so that I can able to handle all kinds of, features, within the shortest period of time, isn't it?
Yeah, but don't you think testing a form or testing a website is a senior QA's job?
No,
Can I answer?
Yeah.
I think you may have some experience in this. And what Rihanna is trying to tell you is that what she just went over was very basic concept. She did not go into details of teaching you Java. And it's not as easy as it sounds. It's just a basic idea. Because when you actually get into the automation, you have to have the intuition to understand what piece or unit you need to automate. That's one thing. Not everybody can do that. So once you have determined what to automate, then you need the understanding of the JavaScript, the writing program codes, and how it interacts with the Selenium. So you need to learn the Selenium software. You need to know the Java script writing codes, and you need to be able to write language into the Selenium so that your test case can be automated and interact with Java and whatever you're testing. So the rabbit hole goes pretty deep later on. And I'm not going to say that she's going to make you an expert at the end of 4 months or so in this field, but you will know enough for you to go out there and land yourself a job, and then the sky is the limit. So you can take it from there as far as you want to take it.
Yeah.
You know what I mean? So basically, you just have to have a little bit of the zeal to go in this field if you don't have any basic understanding at all. But if you do have background in this, in that case, you might pursue some professional certifications and things like that, where you can come out as licensed or whatnot.
Right. Well, the 4 months basically.
Yeah.
Thanks for your clarifications. This basically means basic stuff. And the body motion is basically touch up.
I honestly wouldn't say basic either, because right now I took the same class as you guys, right? And right now I'm doing a lot of advanced stuff, and I'm at a point where I'm the head in the QAs. So I wouldn't be able to do that with just the basic stuff.
Are you using the manual side or?
No, automation. I'm automation UFT.
Are you using also Java?
No, I'm using UFT. It's because my company has licenses. Huh?
It's another kind of UFT.
Yeah. Yeah. Well, I mean, we have Selenium available like everyone else because it's a free source, but we decide to use UFT because we have the money for it, basically. The company has it. So
and one other thing I just want to mention, I think you missed the orientation. The other great benefit of this training is that you get that support in the market. So they work with you on setting up the resume. They give you the tools to build your confidence in this. So when you go out there, you talk like as if you had 8 years of experience. And not only that, they'll back you up with that experience support that, hey, you did actually have
No, that's what I'm
this.
really
So
basically shooting for.
they paved the
Because
path for you.
I'm talking about I'm not just going to get you, I'll make sure that honestly, I expect the person who is going to train us make sure, they have the all kind of background, give us the exposure, so we can able to get the whole scenario in there. That's all. I mean, sorry.
No, you're fine.
You're oriented, or you're kind of when you touch upon so high level. So I understand maybe, but it's still, time is you need to take some time that it really requires for you to explain better.
Right. But the thing is, the people who are here in the orientation days, I don't want to board them. Today is actually first.
We've been through the same thing
Also,
before.
when I call you, you didn't tell me, or you told me actually that today you're gonna go to the orientation, and then you didn't tell the that's what you're saying.
But if you want
If you go orientation is the first you're going to say, and that was that.
that's fine. But those of you guys who want an actual orientation, full orientation, we can do it after class too.
Yeah, let's move on with our topic.
That's the first day.
Yeah, sure. It's
Oh,
Saturday
4-hour
morning,
orientation.
not to.
Okay, so yeah, okay. So very valid question, and I understand why you have raised it because you weren't in the full orientation. And I'm sure because Shata told you we have the 30 minutes orientation, he was probably not clear about it. But we can do it after the class, These guys have been through it already, and they're going to hear it again, and they're probably going to get mad at me. So the first thing we are going to, like I said, we're going to learn about CNFS. So our topics to go over, and there's a homework for you. Like I said, you guys don't really have to submit it. Learn about you. We might do that in the class. Curriculum, overview of last session. That's what we just did. Introduction to computer, network component, and enterprise level application. So okay, so I know this slide kind of seems silly, but what is a computer, right? The computer is an electronic machine, like it says. It inputs and then stores, process, and outputs. A calculator, a computer, computer. You have a phone, which is also a computer. Any machines, basically. Anything that can receive an input from you, like turning on the car button in Tesla, or and then process that information that you are turning on a car, and then produce an output the car turns on. So those are computers, and that's what we're going to be working with. And then we have the components. You have the hardware. I have that grayed out because we're not hardware guys, so we're not going to be learning much about those, but we're going to be learning about the software, the instruction, and the data. What is the data? Any meaningful information that you want to store, like an email. Can someone else give me some important data that we work with, like government offices work with every day? Like important data they want to store about us, like social security number, right? Our address, maybe phone number in some companies. So those are like the important information that we want to store. It is raw, uncompressed information. You can form it into a graph, chart, and so on. So those of you who have Excel, you guys can do this in Excel, but those of you who don't, if you guys have a Gmail account, okay, and go to more. If you go to Sheets in Gmail, get started, download to computer or use on web, whichever you want to, kind of acts as a spreadsheet like Excel. So if you don't have Excel, that's fine. You can also use this to practice. Whenever you do get your virtual machine, whenever we do download that to your computer, you're going to have Excel. So that time you can practice as well. So data, like let's say that I have a small company. Name and employee ID, that is name and employee ID is stored, ABC, ABD, and then we have 1, 2, 3, whatever their employee ID is, unique employee ID. So these are data basically that's stored. So what our goal is, we're going to be learning more about databases in this class, right? We are going to be working with data like this. This is why it's important to know what data is. We're going to be going in actual databases like Oracle and looking at, whose name, which employee ID, 234, and what's that person's name is. And we're going to make query. We're going to ask basically a question to the database, and we're going to find out, oh, okay, name is B. So this is why, it's very important to know about data and databases. Just so you guys know, this presentation here, the CNSS, it's not something that you're going to be doing every day as a QA. But it's something that we want you to know because it's kind of like a step forward. So like I said, like data, right? We all know what it is, but we want to know in depth so we know we can work with database later on. There's some stuff like signals and things you're never going to hear in your job, right? But we want you to know it because think about it. If you go out with your coworkers and they are talking about, oh, this laptop with 16 GB and then 1 TB hardware and things like that, you want to carry on a conversation. So this is why we think it's important, and also it's a stepping stone. Okay, so while back we had what is called an analog signal. Okay, and these are more hardware stuff. Everything that you see is in gray. Mostly the hardware guys deal with, not us, but we still want to know about it. If you can see the analog signal right here, it's going in waves, right? Where we have this as in like a jet and then a backward jet, Z. Okay, the digital signals are binary, 0 and 1, 0 and 1. I don't know if you guys ever see any computer science movies. You will always see this background running up and down to make it look like that, oh, it's very, very smart. But let me show you guys. What binary wallpaper should be, well, you know.
Matrix.
So matrix, yeah. So they kind of show you this, and usually whenever you see a hacker working, you have the zeros and one running up, like they know everything. That's what it's saying. But so yeah, you always see that. That's the binary digital signals, basically digital signals that converts it. So off and on switch, right? So you know the weirdest thing is that whenever you're typing A, right, you are actually turning on and off a bunch of signals to write that, get that word displayed in the back of the computer. Whenever you are turning a light off and on, that's also binary 0, 1, right? So that's how the computer actually works out. But before it used to be analog, then we converted to digital signal. This is physical measurement, continuous. This is discrete time signal, which is 0 and 1s off and on. Then we have the components, and know that you guys don't have to memorize any of this, but just keep it in the back of your head. Hardware components, motherboard, and then what other hardware components can you think of? Give me some old ones.
Cards, PCI cards.
That would actually,
ISA cards.
yeah, you can think about a hardware component. It will probably go more on ports.
Okay.
So
Memory.
yeah, so connectors, input, output. What are some old ports that you guys can think of that we don't use?
Parallel port.
The floppy disk.
Oh, the disk.
Yeah. So the things you can connect it to a computer. Floppy disk, CD. CD is even going away. How back can we go on that one? I think floppy disk
Can't
is
go any further than floppy disk.
floppy disk, probably. And then, okay, so we have, and now, right now, most popular is USB drive, right? So some computer technology, CPU, RAM, USB, BIOS, ROM, right? Here we have a picture of a computer. Like I said, this is very basic. Most of you guys already know it, but we're just introducing, so don't fall asleep on me. We have the speakers right here. Even now we don't use speakers anymore. You have the big monitor, and then the CD and DVD drives, the system unit, okay? Or, you know, some people call this the computer. And then printer, we have the printer. Hard drive that is inside the system unit, the flash drive, the floppy disk, which is pointing right there, but if you look at closely, there's no floppy disk. Then you have the mouse, the CD, keyboard, and microphones, and so on. You can put in joysticks, games and things like that. Those are input and outputs, right? So far, do you guys have any questions for me? Okay, bear with me because this lecture is going to be a little bit dry, but we're going to get there. The first is a little dry. Okay, so then we get into operating system. We have hardware. We have clients now. We have server and clients. Operating system. Can anyone explain to me in like simple detail what an operating system is?
It operates a computer.
Okay, that's actually a good one. So interface between user and machine. Okay, responsible for security. So if you see this Chinese lady, I'm thinking she's Chinese, maybe she's Vietnamese, any Asian, and then you have this American guy on the other side, and the operating system in this case is going to be the translator machine that's in the middle. So that's what operating system basically does. It's a translator. It makes sure that the fact that I'm putting in the word TechFios, it makes sure that the machine is actually writing it on the screen is a job of our operating system. Okay, and then whenever we go more in details, there is two types. There is the client type and there is the server type. You guys, I don't know if you guys actually used Windows 1996, those Windows. What is the oldest Windows?
Windows 995 2.1.
Yeah, so like very old Windows. Even Windows XP, actually Windows XP, I don't like it very much. Right now it's Windows 10, right? Most people use Windows 10. So those are the some of the client types right here. If I go to my property, actually, computer property, I'm using Windows 8 right now. So then we have a server type, Windows 2003, 2008, 2012. So whenever you are going to the job field, you're going to be given a computer from the company to, of course, test their product. And then they're going to give you the computer and they're going to tell you to log in with your credential. You're going to log in, and that login information, believe it or not, see, right now, if I log out and log back in with my user ID and password, I will be able to do that. Can I log in with the same thing in your computer? No, because it's a totally different machine. But in work, whenever we are given all these computers, let's say that my computer for some reason is not working or it's out of charge, I can use his computer to log in because it's connected to a server. So you're going to be, everyone is given a computer usually, and you can log in. One day I left my laptop at home. I used it, I borrowed another laptop, and I logged in from there. Okay, and that is all related to the server. So the way it works, they have a kind of, think of it like a big machine, right? And then you have the internet, and the internet is talking to that server, and then the server is talking to this computer, and that computer. So even if I put in my credential over there, it will work over there. If he wants to put in the credential here, it will work, because it's, at the end of the day, it's all connected by the internet. So that's how the server types works out. Then we have, so for different types, Microsoft have Windows 2003, 2008, 2012. Unix has IBM AIX, and then Oracle, and then mainframe system. So just different types. So thinking about operating system, they're just a translator. Believe it or not, whenever I went to school, there was a class just about operating system.
Oh, yeah.
And only thing I learned is it was a translator. And that's all you need to know for it. Then we have the functions of a computer, right? The CPU, the central processing unit, which is the brain. I like to think about the brain, in charge of all the calculations, outputs, result for input command. Then we have the RAM, which is random access memory, directly accessible to the CPU. CPU cannot access hard drive, and I had a beautiful drawing of that. I don't know if I still have it or not. Yeah, I do. It's RAM is the memory, and then you have the ROM, which is also a memory, but it's read only. Data cannot be changed, stores in BIOS. But did you guys ever try to reboot your system and then it says read only? Okay. Did you ever, let's say that, maybe I can create one here. Do you guys open a file twice? I don't know if it's going to work here, because do you guys ever open a file twice that it says read only on top?
Yes.
Okay.
Excel, it happens.
Okay. So that means that you cannot change it, right? Any values on it because some other software is using it or you're using it.
Typically, it's one person writable.
Yeah, one person writable. And so since it's read-only, data cannot be changed. So that's the ROM. And then random access memory, we're going to go more into details. But before that, if you can see that this has a little star mark in here, it says that CPU cannot access hard drives, right? CPU cannot access hard drive. So if you look at it, here's the operating system. Operating system is talking to CPU. CPU is not talking directly with the hard drive. What CPU is doing is CPU is talking to the memory, and memory is going to hard drive and asking for it, and then hard drive is going back to memory and going back to CPU. So it's kind of taking a it's kind of taking a toll over there because CPU and hard drive doesn't talk directly to each other. So they have to use memory to get the output to the monitor. Does anyone have any questions about this? Okay. Okay. So when it comes to hyperthreading or dual core, I don't know if you guys ever heard this or not, but it usually says that, oh, I have a quad core computer, or I have 16 GB computer, okay, things like that. So hyperthreading is something that we came up with because we want to be able to multitask. Okay, so whenever we heard the word CPU, and if you just look at this box, you'll see just one CPU, right? Whenever we say the word hyperthreading, we give a logical impression that the CPUs has been divided into two. Okay, there's still one CPU. There's still one CPU, but we logically break it into two, thinking that there's two of them. Okay. Sometimes we have quad core CPUs. Quad cores is 4 CPU. It's my brother-in-law. Okay. 4 CPUs right here. 4 CPUs, and then we might have hyperthreading available on there. So how many CPU do we actually have? 8. 8, but physically how many CPUs do we have? 4. 4. 4. So if I draw 4, I mean in here in this picture, if I draw 4, and if you think 1, 2, 3, 4, if all of them are CPUs, and I break it into half, which is hyperthreading, logically we have 8, but physically we might have 4. Now, you guys can, those of you who have computers, you guys can research this, or those of you who don't, then you can talk to the person next to you. If a server has 4 ways of quad core CPUs, then that server has how many CPUs? So it's like a little math problem. I'll give you guys a few minutes to figure that out.
Can you repeat the question again?
Yeah. So if a server has 4 way of quad core, 4-way, okay? So think more logically, 4-way of quad core, then then that server has how many CPUs?
16.
Think about it.
24 32.
32. How did you do it?
Like 4 into 8, because we have a
Hyperthreaded.
8
You're assuming that all of these have the hyper-threading technology.
Uh-huh.
Yeah. So you got 4 cores, and then there are 4 ways.
So if we hold on 1 second, give me a second. If we have 4, let me try to do the drawing here. Okay, you're saying 4. Okay, you're saying?
And so, and hyperthreading is only twice, right? It just breaks the CPU into two, or does it do 4 ways? Like, does that 4-way means that's a 4-way hyperthread?
So think about it like this. We broke it down to 4-way. And if we hyperthread that,
Okay,
so how many are there?
32.
So kind of imagine this is broken into a little bit more of that. So do you hear that term a lot? The 32 GB? Whenever, whenever iPod was really popular, you can get either 16 GB or 32. So if we did not do hyperthread, how many would we actually have? 16, right?
Are you talking about the bit, like some operating systems are 32-bit
Yeah.
and 64 now? What I
Yeah.
see is that
Mm-hmm.
connected to this?
Yeah. So if we break it into, but physically, how many do we have though?
16.
How many? I should say how many core CPUs do you have?
4.
4. But then we have it in 4 ways. Now, logically, how much space do you have?
32.
32. Yeah, that's basically it. I'm glad you guys at least stick with 16 or 32. Usually class goes over 8, 6, 5. I don't even know how they come up with the number, but it's pretty cool whenever I ask them. So why do we need that logical or why do we need that logical multitasking power, multi-threading power? Why do we need to use it? So whenever you have a CPU, okay, what happens is that if you give it one task, okay, imagine the CPU is a waiter maybe or a cashier. So if one person is checking out, okay, and there's another person who is trying to check out, and there's only one person here, then he has to check out this person first, right, whoever came first, and then after he's done, he has to check out the next person, right? Okay. But whenever we hyperthread, whenever we give the CPU the impression there's 2 of them in there, so now, probably a bad example, now this cashier thinks that there's 2 of them. You have task 1 going in, and then using this, you're completing task 1, and you have task 2 that is going in as well, and using this, you are completing this task. Right? Now 2 tasks is going into it at the same time. Multiprocessing power. Same thing. So if you have 2 CPUs now, and you have 4 at the same time, even though there's only 2 CPU, when you hyperthread, you're going to have 4 tasks going out at the same time. So that's why we came up with the logical part of it. Instead of getting 4 CPUs, we're going to get 2 CPUs and make them think like they're 4. Okay, that's basic.
And if you give them 5 tasks at the same time, does it crash or does it wait in the queue for?
It will sit in the queue. In this scenario, it'll sit in the queue till whoever gets done. Okay.
So if we have more tasks,
Mhm.
let's say handed,
Uh-huh.
how it's work?
So like how it works in the computer right now. So if you open up like 6 or 7 softwares, what's gonna happen? if you click on 6 or 7 softwares together. It's going to slow down, right?
It opened different windows.
Exactly. Yes. So it will open slowly, one at a time, right? So something like that.
It affects the speed of the computer.
Exactly.
But the task will be completed according to the entrance of their priority.
Yes.
The window that we click at the first time will serve first, and first come first serve. It will be first come first serve. Yeah.
See, that's the whole core, the task thing that's going on. See, that's why our computer is getting faster. You know, think about 10 years back, it used to be a lot more slower, and now it's getting faster because we are coming up with this hyper technology to make sure that we can do it at the same time. But it's a computer, right? So whenever you're opening 6 tasks at the same time, your computer still is slowing down a little bit because it's trying to complete one task at a time.
Rihanna, but this scenario might change in case of networking. When we are working with a large network, or when we are working in a mainframe environment,
yes,
the speed will not affect that.
Right. So you're thinking more of a network perspective, internet network perspective. But if you're just thinking about a computer without any like network, you're just opening local software here as a single user. Yeah, personal computer. Then yeah. But if we're bringing in network, we're bringing in other factors too. So that one. So if you guys ever open up your task manager in the background, you'll see all the software that we have open, right? Do you guys ever use this? Whenever a computer gets stuck, we do Control Alt Delete, and then we get this task manager, and then we force one of them to stop. So whenever you click on more details over here, you can see the processes that's in the background. You see how Google Chrome is like, it has so much of open. And then if you look at it, it will give you the percentage of CPU that's being used right now, right? GoToMeeting is using 21.8, of course. Then you can see the memory, disk, and then you said network, right? So look, the network is also calculator over here. And the last one, 1%. Okay. So these are called processes, right? So what do we mean by process versus thread? An executing instance of program stored in the main memory. Several processes may be associated with the same program. Multi-process system, multi-process running in parallel execution. So when we say processes, this is probably the simplest example. These are all processes, and it's running in front of our eyes or behind the computer, right? And then when we go to GoToMeeting over here, they're like jumping around like crazy, so I'm gonna stop this. Okay, so whenever you look down this list, you will see errors in some of them. Okay, most of them has one, but some of them has a bunch of it in under it. Okay, these are called threads. Okay, they're subsets of processes. Executes within the context of a process and shares the same resource allocated, may execute concurrently of the process. So it's using the same thing, but it has its own subset, right? But it could be that they're using each other. It could be that it's using the mainframe, but these are called threads. Okay. So process and thread. Any questions?
How long the process will stay in the RAM?
How long the process is going to what?
Stay in the RAM.
How long the process is going to stay in the RAM? Till you stop using it. So if I turn off, for example, if I turn off Microsoft Word, if I can find it, let's see. By name. Okay. That stops it. Do you guys see it on the list by any chance? Okay. Okay, maybe something else. Okay, for Google Chrome, for example. So I'm going to go ahead and close this. Okay, CPU 0, memory 3.1. I'm going to go ahead and end task. It's going to go away. It still might run some extensions in the background, but it's basically out of our processing right now. So if you look at it, it might have some background process. Let's see. Chrome. Nope, it's gone. So the memory stops. Okay. We're going to go over virtual memory in a minute. But before that, the zeros and ones that we're talking about, we're going to go over that. So this is going to be more hands-on. You guys can finally wake up, because I know that last part was really boring. But this is actually pretty interesting. A lot of people ask me, do I ever use this in my QA job? You know, do I ever use it day-to-day basis? No, you don't. Do you need to know it? Yeah, because you are going to be in the computer industry, IT industry. So you should know how this works. And it's honestly not that hard, the zeros and ones in the background. So we have number base, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, or 9, up to 9. Number base, there's 10 digits, right? We have binary base, which is 2, 0 and 1, 0 and 1. And then we have hexadecimal, that it's mixed with letters and numbers, right? But before we go into hexadecimal, we're going to take our regular day-to-day number to binary. Okay, we're going to convert it and then convert it back. Okay, so I'm going to open up Paint over here. Paint. Okay. Now, as you can see over here in the binary, okay, and then decimals, this number right here is very important, okay, and you will see how it increments. So you have 1, right? Then you have 2, okay? 2 plus 1 is 3, right? So we're not going to put that on there, but we're going to put 4. 4 plus 2 is 6. We don't need 5, because 4 plus 1 is 5. 4 plus 2 is 6, so we don't need that. 4 plus 2 plus 1 is 7, so we don't need that, but we're going to put 8. We're going to increment it. 8, 16, let's see, 16, 32. Do you guys see the pattern? Yep, 64, 64, 128. Okay? So, let's say that I want to write the number 9 in binary. Okay? So what I'm going to do is that I'm going to go ahead and turn on number 8. Let me get a better brush over here. Turn on number 8, right? Our goal is to get to 9, right? So we probably don't need 4. We don't need 2. We need 1. 8 plus 1 is 9, right? You can put 0 zeros in front of it if you want to, okay? But not after it. Not after it. It actually works backward. Usually, whenever you are writing in decimal system, you can do 12.00. This is equivalent to $12, right? Right? But whenever you're in binary, if you have 1, 0, 0, 1, and if you decide to add another 0 to it, it becomes a completely different number. But you can add as many zeros you want in front of it. Okay, so now we have 9 over here. Let's try to do 10 over here. So we're going to turn on 8 again. Okay, and then we're gonna, that's a 1 by the way, 0, probably 1 right here, and we don't need the 1, so we're gonna put a 0 right there. So 1010. Okay, let's see if our calculation is correct. Decimal to binary converter. Okay, so we had 1001. Oh, this is doing decimal. This is decimal, yeah. Okay, so 9 is going to be 1001, right? And we did 10, I believe, yeah. Convert it, 1010. Okay, does anyone understand how we're doing this?
When you use this chart, actually it's simple. If you
Yep.
use that chart.
Yep, but you also have to know how to come up with that chart too. So it's just 2 times 2, 4, 4 times 4, 4 times 2 is 8, 8 times 2 is 16, like that. But yeah, it is simple. So what if I do it backwards? Okay. What if I decide to do, I don't know what I mean, 100101? What if I decide to do this number? What is my answer? Hold on 1 second.
So okay, you change the screen.
Yeah, sorry, there you go.
So this one is, okay, the first one on the left is 32, right? So 37.
Okay, let's see. We have 1, of course, and then we're not using 2. We're gonna use 4. Oh. Okay, we're using 4. You're not using 8. We're not using 16, but we're using 32.
So just convert all the digits and then add them up. That's probably the simplest way to do it.
That's the most common way. So whenever you see all the zeros and ones flying around in the background and we get intimidated by it, there's actually nothing to get intimidated about. Okay, so do you guys all feel that you guys can do this? Okay.
Can you show it to the simple way like he was saying? Because I'm still confused.
Okay, sure. Okay, so so you have on and off switch on all of them. Okay, all the numbers, imagine that you have on and off switch on. Okay, let's say that I want to make 18, right? So I'll probably want to take 16, and I probably want to take 2 off here. In on, 1 is on, 0 off, right? So we turned on 16, we turned on 2, but 8 we're going to turn off, 4 we're going to turn off, and 1 we're going to turn off.
But then you said 1 is on, so I'm not.
Okay. Can I interrupt?
Yeah.
I'm sorry. So I think the best way for everybody to know, in my view, is to make that chart before you do anything.
Okay.
You have to have this chart handy in front of you.
Right.
So, like for example, 1 is 1, 2 is 10, 4 is 100. So you have to have this chart available. Then they can use the chart to convert back and forth.
When you say chart, which chart do you mean?
Like, they have to know exactly what 121 represents. 128 represents, right? The 8 bits that you're talking about. So, for example, everybody has to know what 1 parallel in decimal, 1 is in binary, which is essentially 1. 2 is essentially 10.
Oh, I see what you mean.
So they have to have a reference point somewhere because it's not actually simple.
It's not?
No, I mean,
Okay.
from the layman's point of view,
Okay.
it's not simple.
Absolutely.
Okay.
You can't do this in your mind.
You can shed me light.
If you have a chart
Yeah.
slice.
What I can say is to say, this is first of all, if you realize what he was talking about, I'm just trying to get a little bit extent of communications. Like 37 we did, right? 37. We put 3, 7. 3 actually basically 4 bits. 7, another 4 bits. Okay? So make it first like a 3, 0, 0. I mean, first make it whole 0, 0, 0, 0, 0, 0, 0, 0. Now that you have the, the kind of like first 1, 1, 2, 4, 8. 1, 2, 4, 8. Then 30. What is 30? 30 is like, when 30 is a 3. That means 0, 0, 1, 1. Then 7, what is this? 0, 1, 1, 1. Once do this one, then you go again like, what is on 1, 1? Then you have a 1, 2, 1, 1, 1, 1, then 0, 0, then 1. Then 32, then you do 1, 2, 4, 8, 16, then 132, then you have 32, then 4 plus 1, 0, 1. You have 1, 0, 1, 1, 7. That's the way I think is better. First, you have a 2 separate 4 digit by 4 digit. The 1 byte, 8 bits. So everything like I put 7 0 7. That like a 0 1 1 1. That's 7 0 0 0 0 0. Then you go left to right. 1 2 4 8 16 32.
Okay, I need you guys to clear your head.
Yeah.
Clear your head for a minute. I see what you guys are having issues on.
Yeah.
Okay, clear your head and
Yeah.
clear your head for a minute, and this is what I want you guys to do. Write this number down, and I'll tell you how to get there one step at a time. And we're gonna play a little bit of game. Okay. I want you guys to look at this number only. Don't worry about where it came from. Don't worry about how we got it. Just look at this number. Okay?
Okay.
Yeah.
It's 255 altogether.
Right. Oh no, don't count it. We're just gonna play a game. Okay? We're gonna say no, this is going to be just empty. 18, yeah. 38, 140. Okay? Now, I want to don't think about it as a binary or anything. I want to get the number 18 from these numbers. Okay? How do I get it? Okay.
By adding, right?
Yeah, by adding.
So 16 plus 2.
Okay, so we have 16 plus 2.
We have two ways.
2 ways? Are you sure? Okay, so what is 2 ways? Oh, okay. See, the thing is, whenever you add up 8, 4, 2, and 1, you're going to get 15. That's why the number is not on there. So you only pick 16 and 2, okay? Now, on that one, since we're using those two numbers, I am just going to, the numbers you use, I'm just going to put a 1 on it. And the numbers you did not use,
Yes, it's a good trick. I like it.
I'm going to put zeros on it. Okay? Now,
So what is 1 for? Because we choose those numbers?
Yeah.
yes.
Basically, it's on. This is what you're taking. So
Okay.
it's
That's where I was confused. I'm like, why is this 1
Yes,
for?
because the computer only understands whether there's electricity coming in or out.
Yep.
So the logic has been built in a way that if there's power coming in and out with that sequence, they can pull out different data. And that data is going to be 18
So on
in that sequence.
Now I got it.
okay. Now someone do 38 with me.
32.
32.
Okay.
And there is 6 different, 4 and
So I'm gonna put 1 or 0 here.
1.
1. And then where?
4. 4.
Okay. I put 1s on this one. I'm gonna delete this.
Take a picture.
Then 0, 0.
Okay, I'll take a picture and I'll send it to the group.
So guys, that the one I was showing you before, that's the same thing. I think my drawing wasn't pretty.
Yeah, it's a very good reference point.
Okay. Let me pull this down a little bit so it's in the same one. Okay. What about 140?
128, of course.
Uh-huh.
And then 28 to 40 difference is what, 12. So you take 8 and a 4.
Okay. 8 and 4. So meanwhile, I'm gonna make everything else a 0. Yeah.
What about the big numbers?
I'm sorry?
What about the big numbers? You have
Bigger number? Okay.
256.
so the chart will increase to double the
You probably are not going to need anything.
and then you have the bigger.
Let's say we do, right?
Yeah.
Take that number.
Like 128 times 2.
Times 2.
Typically, these numbers don't go bigger than 8. And if you have to calculate, it's not bigger than
Yeah, it does
Then
that.
you can multiply too, right?
Yeah, multiply 2 every time. So everything multiplies by 2. So let's say that we want to go up to 1,000, then we can use 500 and so on. Or if you decide to go up to, I don't know, 1,500, then you can use this.
Can you show it?
Yeah. So show what?
Do an example.
Oh, do an example. Okay.
I give you 1500. How are you going to write down all of that?
1500.
And
1500. Okay.
You have to extend
You have
more.
to extend it like hexadecimal.
No, actually,
No, you don't.
You
don't.
No, you can have it,
256.
yeah.
You can do 256 after that.
Right. So you have 1500 minus 1024. I'm just doing the math over here. So we need
256.
about 256.
So 476 is 220. So you need
256.
You need 128.
220. So I need 128 and 64. Let's see. No, 64 is too much. Oh no, not 128. Yeah, 128, 62, and 32. Yeah. So 220 now minus 128. We have 128 minus 64 minus 32. We have negative 4.
So you can reduce
Okay.
30. You have to use 16,
16.
8, 4, 2.
Yeah. 4, 2. Okay. So we decided not to use 32. So that's good. We're going to write down 16, 8, 4, and then 2. Negative 2.
Oh,
So that means we're not going to use 2.
I think there's a mistake.
No.
32, 8, and 4.
So let's go by here. Actually, the easiest way to do this would be this. I'm going to sum this up, right? So everything we're going to use, we're going to actually put the number on it. So 1024, that's good. Then we have 512. Okay, that equals up to 15. So we're not going to use that. We're going to use 256. Okay, that's 1200. That's good. 1280. Then we're going to use 128. Okay, we're going to use that. That's 14. Okay, we're going to use 32. Okay, that's 1440. We might use 16. 1456. 8. 1464. 4. Okay, now we have to use 64. So let's delete this. Think of it like a game. 64. Okay. 1472. Then we're using 16. 1488. 8,
And 4. And 4.
4. 1500. So if that translates, so I'm going to turn this one on, this one off, this one on, off, off, or on. Do you have to write the zeros at the end? Yes, you have to. Because what happens if you don't write the zeros at the end? Then this becomes 1. This scales. If you don't write the zeros at the end for this scales become shifts, basically. I couldn't shift it anymore, but anyway, shifts. So this is it. So let's just check if our number is correct. 1500. Convert. We have 10, 11, 10, 11, 1, 0, 111, 00, 1500. Okay, now deleting this. Okay, now let's do it backward. It's actually easier both way. Like if you add it up and subtract, it's much easier this way. You just don't have to you can't think too much about it. You have to think of it like a game, honestly. Then it will work out. So someone convert this for me. 74? How is it 74? Okay, 64. So 74, yes. Okay, 74.
17.
Then we have 16, 17, 18, 19. We have 19. 19. Then we have 4 and 6. 6. So now everyone can translate back and forth. Okay. So that's what numbering and binary is, right? Conversion. Now let's come to hexadecimal. Okay? Yeah. Yes, I believe so. Yes, it's recording. Online question, you guys been quiet? Do you guys have any questions?
What about letters? A, B, C.
Yeah. We're gonna get to that. Yeah. Online student? Online questions? Do you guys have any questions? Do you guys hear me? Are you guys still with us? Okay. So now they're very quiet. Either that or for some reason I cannot hear them. So now we're going to go ahead and start converting from binary to hexadecimal. Okay? Or let's see if we can have decimal to hexadecimal. So honestly, I'm going to tell you the easiest way to do this using a chart.
Yeah.
Using a chart, yeah.
Take the letter, translate the number.
Okay. There is a way to do it, and we are going to do it after we take a little bit of break, but basically there's a chart available right there. Okay, the easiest way. So if you are trying to figure out what hexadecimal A is, then you're probably going to use decimal number 10, right? That translates back to binary using this chart. So it's all interrelated, and we're going to do that in a bit. Those of you who don't want to take a break, you guys can go ahead and search for hexadecimal a little bit more, but we're going to take about 10 minutes break and then meet back at 11.
Almost all the calculator you can do it.
Yeah.
All the calculator.
Yeah. it's just understanding why to do it and how. But yep. There is coffee available. Shajat made it, so if you guys want to grab some coffee, let's say that we're gonna be back by 11. Huh? How much is coffee? Oh, if Shajat makes it, it's free.
So he's probably not that
You
good.
probably he probably will pay you to drink it.
So he's not good.
11 a.m.
Ita muna to because you did not use me. Oh yeah, sure. I'm glad.
They say to block your schedule till 2 p.m.
Actually, the email that they sent me to show that it is an orientation from 9 to 10.
Oh no, that was like
Yesterday I received an email from Chef. That's why I have some important commitment at 11:30.
okay.
So
Well,
I
you
am
can
a
have
bit uncomfortable to
Sure.
use this.
What you can do is this meeting is being recorded, and talk to Shaz. He will probably send you a link in your email, and you can open up and watch this. So you're not going to be missing.
May I know the name?
You can call me Stein. Yeah. Are you from Bangladesh?
No, I'm from Pakistan.
Pakistan? Okay. There's training tomorrow too,
At what time?
same time.
Till how long?
So-
From 10 to?
Yes, she missed a lot of things that she kind of touched base on. Like the way it works is from 9 to 2, Saturday and Sunday, every weekend.
Yes, they told me, but for today they strictly send me an email that this orientation is between 9 to 10. That's why I put an appointment at 11:30.
Yes. Well, the fact is now, this weekend is not the orientation, it's the first class start, so we have today and tomorrow.
Tomorrow I am available for the whole, because I know it.
Sure.
But right now I have an appointment, so I have to talk to her.
Yeah, talk to Shaz, and he'll give you a link. Bangla nam Ridu,
Regal.
and you can call me Stein. Stein.
Stein? Oh, that's good. আমার কম্পিউটারের কোনো ইয়ে নাই, idea নাই, I'm just
Oh, don't feel
trying.
bad, I'm the same way.
I'm trying, so thank you for.
No,
Because
you're
she was going, I was a little confused the way she was going.
Well, the way she was attacked, she felt like she needed to go faster. You know what I mean? But I think he's in the pros. Yeah. Asking the pro question. Yes.
So we are the beginner, so
Yes.
then
Yeah.
this is not his class then,
Yes,
right?
yeah, and it's designed really well. That it starts with very simple to include everybody.
Right, right.
But just hang in there, and we'll kind of work together to pull it through.
Thank you.
So,
আমি কি করেন?
আমিও computer এত কিছু না. Let me just.
আপনি কিছু করেন?
Yeah, I teach. Teacher.
School?
School.
Oh, which grade?
এখন তো সব গ্রেড আমি বাসায় গিয়ে পড়াই,
Oh,
বাট এটার আগে আমি 5 বছর হাই স্কুলে পড়াইছি।
আচ্ছা। আপনি পুরো চেঞ্জ করে ফেলছেন।
হ্যাঁ।
আমার দুইটা কাজ আমার করতাম এতদিন, so I'm now trying to change it and let's see how it works. আমাদের রেস্টুরেন্ট আছে চামেলি, and plus I do some hair and beauty stuff.
Jamili Restaurant, Richardson.
Richardson.
আমি তো খাইছি হ্যাঁ
ও আমাকে বলছে, বলে গেলে ওখানে দেখাবো অনেকের সাথে ধরেন তা দেখে না জানা ওই দেখি আমার I was like I don't have any idea. So then my siblings are there, so they are taking it. They are also pushing. They are like, okay, come with us.
আচ্ছা তো তারাও কি এই ক্লাসে নাকি?
হ্যাঁ, এই যে কথা বলতে যে তুমি আপনার সাথে এরা ফার্স্ট আমার ভাই Okay, thank you. Meet you tomorrow. She said she is going to send the link.
Okay.
I will get update at first. Because my daughter has an appointment with the doctor, I don't have any information about it. Okay.
Okay, so see you tomorrow.
Thank you.
Yeah. Yeah.
আমার এই ভাই বলতেছে এখন শুরু হলো আর আমার বোন আবার অনলাইনে ইংলিশ শুরু হলো তাই না
নমস্কার তো বিজনেস কিরকম চলতেছে আপনার
ভালো আমার হাজবেন্ড করে আমি জাস্ট সাইডে and my main business ছিল আমার ঘরে পার্লার my man now but here I'm still with this I have this education that I can make it part of
না এটা তো একদম এক্সট্রিম টাইপিং এর কিছু না না হয়তো একটু টাইপ করতে হবে বাট আস্তে আস্তে তো আপনি এরকম লিডারশিপ পজিশনে যাবেন যে ইউ হ্যাভ পিপল ওয়ার্কিং আন্ডার you'll be doing it for you.
So good luck আপনাকেও আমরাও চাই দেখি
Another question I think he was last history working in the calculator. But that's it. Money levels that way. See that thing. It might not have lasted. They was thing. Stroke recently. Should I take all even share that stroke is a game dementia was slowly getting going. And I was thinking, gosh, what do you think fixing days? Now definitely more often. It is swelling to his one ashore. Yeah, it is another thing that I compare to. I was having another yeah. But that's not what she's saying. Barely more. All those things going on doesn't that's a tough time. It's gonna get worse to all of these passes. This is a blessing in disguise. So, তার মধ্যে যে একটা ফিলোসফি হবে না what my father did শিখিয়ে পারবা ওইটা দেখা সব আমার মামা ইন্দিগোর কাছ থেকে আর কি আমরা ইন্সপায়ার্ড তো আপনি শুরু করছেন অনেক বাঙালিদের কেমন হয় হয়তো আসবে বাট not on the IT field.
It's very different than what you say. I mean, what you use.
I'm in LinkedIn connection request. We can have that resume and find the job. That's a good strategy. You have team bullet job.
I also used to do all those ads.
Okay, after we did the
Award and all. I hope
like after profile যেখানে যে জব গুলি দিয়েছিলেন that's a good idea. Maybe not Bangla now, but next time. So, how many years have you been
And you went into but don't take these things too seriously. I don't think you're going to need it to. I mean, it's good to know, but
I have knowledge of it.
nobody uses calculator. Yeah, I mean, I never used it in my life. Used calculator all my life.
You have to know.
খালি পরীক্ষা টরীক্ষা যদি সার্টিফিকেশন পরীক্ষা দিয়ে দিতে হয় এগুলো জানতে হয় সার্টিফিকেশন পরীক্ষা দিয়ে
মানে আমি এই ব্যাপারে অনেকজনের সাথে আলাপ করছি বুঝছেন মানে অনেকজনে মানে ওরা ইন্টারেস্ট থাকে এখানে মানে
আপনি একদিন আসেন না কেন আমি আপনাকে বললাম
আমি অ্যাকচুয়ালি ওই যে আমার সময় হলে ওনার সময় হয় না ওই কারণে আপনি একদিন আসলে মানে আপনি যেদিন থাকেন আপনি বলেন তাহলে
আপনি আমাকে টাইম না আমি তো টাইম ব্যবস্থা করতে হবে আপনি
আমি সেটা আপনার আজকে কালকে সোমবার পর্যন্ত ফ্রি
আজকে কালকে আমি মিট করতে পারবো না আমার প্রসেসরি আসছে আমি সোমবারে মিট করতে পারবো সোমবারে আপনি
সোমবারে এই টাইম
সোমবারে
আবার সোমবারে
যারা
ওনারা আমার কাজে বুঝছেন
আচ্ছা ওনার ফ্রি আছে আচ্ছা সানডে ইভিনিং এর আমি ভাবছি সানডে দিন 7টার সময় আপনার কয়জন
আমরা মানে আমি চাচ্ছি আমাদের বাংলাদেশের একজন আছে
আপনি আমার বাসায় আসতে পারেন যদি বলেন যে আপনার সানডেতে 7:30
So when you're senior someone actually you don't physically do the automation testing and what you just do the leadership.
So it depends on the company. Some companies.
সাতটাও ঠিক আছে সাড়ে সাতটা আমার জন্য বেস্ট
Senior, it doesn't mean you are the manager. You still have QA lead or managing. So they are managing the team. You are just the senior quality assurance analyst or something like that. But you're gonna do the same work.
So same you gonna know.
Yeah,
actually
that's the
The difference is the key
আমার এই কিউ মনে করে সেই জন্য আমি মাই রেজাল্ট দেখবে আমি যদি honestly very easy job I'm আমি ব্যবসা করবো তো বাইরে বলতে next 2 years
and sometimes
I do not care for money anymore আমি মরে যাবো টেনশন
but you don't have to. If you don't go to like lead or managing role, you don't have to manage it.
আর তাহলে কি আপনার এই লিড যে সে এই কেস গুলো ই করে তারপরে অ্যাসাইনমেন্ট দিয়ে দেয় যে
উনিও ফ্রি আছে
আচ্ছা ঠিক আছে তাহলে 7:30 সময় আমি আপনার কম্পিউটার উপরে নিয়ে আসবো আপনি যদি দেখো but আপনি ordering it how to
I'm finishing this by this day.
আমার খেয়াল আছে মানে আমাদের বিজনেসটা আছে না দেশে
They are not, nobody will apply it. Your manager,
আপনি আপনার জন্য সবচেয়ে বেস্ট আচ্ছা আপনি I'll tell you
I need 8 hours for this.
and then you independently work on that assignment.
আপনি যদি নিজে চেঞ্জ করেন then you can say those money is basically coming back to you.
So yeah, we'll give everything. Just consumption of the cost, we'll give everything. After basic, we're gonna take the do the SDR.
অনেক মানুষ অনেক বড় নাম্বার বলে
So there on that class,
How does it
আমি দেখি আসলে অ্যাকচুয়ালি ওই যে আপনার ওদের টাইটেলের মধ্যে যে ইয়েটা থাকে না তার যে প্রাইস থাকে না ওইটাই তো অরিজিনাল প্রাইস তাই না যেমন
at the end of the day,
Okay, let's see. We took extra 5-minute break.
Maybe you can tell next time 5 minutes. So we'll take 10.
Oh yeah. Okay, online class. Are you guys back with us? Can you guys all hear me? Yeah. Is everyone still with me? Yes, okay. Okay. Okay, so on the right side we have hexadecimal. It shows F 5F, right? And then it was converted into binary and then converted back into decimal. So let's look at the conversion right here. I want to get rid of this. Maybe put it right here. Okay. Hexadecimal conversion. It should give us a chart. Okay, perfect. Hexadecimal conversion. So we have the decimal numbers right here. Okay. And we have the hexadecimals. And then decimal, hexadecimal, decimal, hexadecimal. So if I say that what do we really use hexadecimal for? One thing that is really popular, does anyone know? Okay. So whenever we are picking a color on the computer, let's say that I want this color right here. As you can see, do you guys see this? It's pretty little, but you can see the number changing right here. You can see the number changing. So if I put 0, 6 zeros, is gonna turn, if I change this to 3, 4, 5, 6, 6 0 is gonna turn completely black. Putting 6F is gonna turn completely white. These are hexadecimal numbers. Okay? This is what we use hexadecimal for. So whenever you're creating a website, for example, there you go. Okay, so whenever we're using W3 School, and I'm going to introduce you guys to W3 Schools a little bit later. We are going to be using this site a lot. It's a very good site. Yeah. So it's a live on training. So that's what I like about it. It's not using hexadecimal. Let me see. W3 School hex color. I wish they would show. Okay, they're not showing it. Okay, let's go a little bit lower. I'm trying to find a good example here. Run. Give me 1 second. Let me look at this. Okay. Okay. So this 00006 zeros, the hexadecimal color, I went ahead and changed it. If you visited this site, then turn into this color. So whenever we are building that website, I told you in a couple of days we're going to be building a site, very simple. We are going to be using the color in hexadecimals. If I go to Google, okay, if I look at the back end, okay, then you will see, let's see if I can pick this one. And don't worry about learning this. This is not something that we need to learn right now. But if you look at this, it's going to tell you the background color. You see the background color, it has that F2 weird number. Okay? And we can change it. So anyway, so even when they're coding in the background, this is the code in the background, you can see that they're using hexadecimal. Okay? So this is why this is the most important thing. So whenever we are doing hexadecimal conversion, that's one important thing to keep in mind. That's where we use it most on. Now, if I say that I want hexadecimal converted to decimal, 1F4, what would you do? Just look at the chart, right? Okay. Let's look at hexadecimal conversion. So here they show a simple conversion, and every time I do this, it's always very confusing. But they are turning into hexadecimal number into a hexadecimal number into an actual decimal number. So we're gonna use the actual calculation. Okay, so it's gonna be kind of like another game too. We're gonna be playing the same game, just a little bit different. So looking at this, we have 4F7A. Okay, going back to our presentation, know that hex base is 16. So there is 16 different characters. There's 10 different characters in our regular numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 2 in binary, 0 and 1. And there is 16 in hex. Okay? Keeping that in mind, we are going to follow in Excel. Same thing, but a little bit different. Okay? Okay. We have 4F 7A. 7A. Okay? Now, we need to find what A is, what 7 is, what F is, and what 4 is. Okay? So we're going to break that into different categories. So we're going to do it backwards. We're going to have A, we're going to have 7, we're going to have F, and we're going to have 4. Did it a little bit backward. Okay? I'm setting it backward. Okay? And then I'm going to go to my chart right here. And I'm going to figure out what they are. Okay? This is on my way. So I'm going to have this in one side now. Just on one side. And then I have this in one side. And then I'll have this. Okay. So what's A? In decimal.
10.
10. 7 is 7. F,
150.
50, okay, and 4 is 4. Okay, now taking this number, okay, we're going to times this. Okay, I know this is an X, but imagine it's time. 16, 16, 16, 16. Okay, so basically what this guy right here did. Okay, but now we are gonna introduce power as well. To the power 0, to the power 1, to the power 2, to the power 3. Do you need to memorize it? No, probably not. Just know how it's done. There's no memorizing needed. And I have this on the side because I don't have it fully memorized. So to the power 3. So we're going to go ahead and convert that. So doing the math right here. So we have 10, then we have 7, we have 15, and we have 14. But then we have the to the power right here. So 16 to the power 0, right? 1. Okay. Then we have 16. We're just going to do it for that. And then we have to the power of 2. Equal. There you go. And then we have equal sign 16 to the power 3. Yep. Okay. You take all this number and you add it up. Or you times it. Oh, okay. It didn't time it. Sorry. You have to take this times this number right here. So we're missing a step. Times this. Okay. Do the same thing for rest of them. You get that number and then add it up. So you get the same as that. So basically what we did, we took the number, kind of flipped it over, and then we took what the conversion charts say. We times it with the first is going to be 16 to the power of 0, then 16 to the power of 1, 16 to the power 2, 16 to the power of 3, and so on. We did that, and then we did the times, 10 times whatever that was, and then got this number. Okay, that's what it converts down to in decimal. Okay, now do we need to actually know how to do this on top of our head? No, but this is how it's done, right? So if you ever need to go ahead and turn something into decimal from hexadecimal, use a converter and just do that way. Or if it's something small, use that chart that we brought up right here. Okay, gives you that number. So does anyone have any questions about that? Yes.
So how is this number, so to 20,000 or even the 4F, 7A, relevant to like in the computer? Like, does it predict a location on the screen?
Okay, so you have to think about it like this now. So imagine this number 20346 turned into binary.
Okay.
Off and on, off and on, off and on.
Mm-hmm.
Okay, that turns into a color.
I see. And how does that happen?
So going back, I might not even have the answer to that one. So going back, if you look at the whole color value, I'm sure the computer has it in some way. I'm not sure about the engineering in the behind of it, but you see the RGB and the numbers converting. I guess it points as we go, and that's how they figure it out.
So there is a set number to color ratio set up somewhere?
Yes.
That's universally used?
Yeah. So and they have this screen, so maybe each of these colors, like BA0D0D, has a binary number in the background that is saved. And then that's how it works out. I'm sure there's a lot of calculation involved too.
So we have to convert this number to binary?
Right now? Right now, no. You don't have to. Just know how to do it. In your everyday basis, in your job, no. You don't even have to do the binary decimal. Yeah. You hardly ever have to use a calculator. So.
But
So
I
you're saying,
suppose
so
if
you're
someone,
saying,
sorry.
oh, I'm sorry,
Okay.
go ahead.
Yeah, so if someone is developing a website and want that color, would they have to have that chart?
No.
No way.
No, you don't need it.
Oh, good.
So if you're developing it, then you use the hexadecimal
No, but
number.
what I'm saying
But even the
is,
hexadecimal chart to the color ratio, do they use some sort of?
So right now, as of today, no, you just look it up like this. But if you were, let's say, going back, if this did not exist in Google, if you're
Yes.
saying this did not exist in Google, then yes, you would look at the chart and you would try to have to figure it out. So this RGB, then you have to do hexadecimal to RGB. So we are really thankful that this chart exists. Yep.
like if I had to develop from the scratch,
Uh-huh.
have a node, then I'll do that, look at the, whatever the existing color, whatever the color has been existing, like as you did, look at the, what code was pointing to which color.
Uh-huh.
From that point of view, we can use
Exactly.
But there are a lot of functions already available. You can call it functions.
Yeah, so the most common one, without even looking at like the FFFF I did, right? It's 6, okay? So we know that's white, right? I can usually use that. Let's say that I want to change it up a little bit. The first two, I believe the first two in the hexadecimals is the red, and the second two is the green. Let me see. Maybe. And then the last two is the blue. So taking that number, I'm sure like if you did not have this tool available, you would change it around here and there and then try to figure out. I think 00 FF 00 is green. Okay. Yeah. So you take it up.
I think that's why they call RGB, red, green, blue.
Yes. Yeah. That's why I did. See, if you see the red, it's 0 at 0, and then if you see the green, it's at the maximum to 55, and then the blue is at 0. So if we want to change it around a little bit, 0011. I can't see because of the green, but it goes up to 17, so I guess it's a little bit darker. Okay, it gets a little bit darker. So yeah, if you did not have this tool available, then you would mess around and then of course turn certain colors. Back then, what they used to use before this was available, they used to have charts like this. Actually, we have charts like that in our company because there's only certain colors that we can use. The blue cannot be exactly the same blue as some other company, so they give us exact hexadecimal we have to use. So for example, like the tomatoes at colors like that, maybe, these are W3 schools colors and they have a hexadecimal for it and then they will just give it to you. Okay?
So if you don't mind, repeat it again about the thing. I understand a little bit, but repeat it like how did,
The conversion?
yes.
Okay. So the conversion, the way it worked out is if I give it in a math formula, then it will be like this. Like this. Okay. Okay. So you have a hex number. Okay. You need to go ahead and take that number. This is process 1. You need to take that number, rotate it. Okay, rotate. You're going to take that number and then the second step would be to find the translation of each and one of them. So translation as in conversion for each of the character. Conversion of the character, that's that. conversion of a character. And then this is how it works out. Conversion of hex, that's hexadecimal conversion, times base
Location.
Base 2, because there's a cloud effect.
base 0
Yeah, and depends on the location of your digit within that number.
Yeah, but I'm trying to say this one.
Basically 0, 1, 2, 3.
Yeah.
0, 1, 2, 3.
Yeah, 0, 1, 2, 3. So let's just do 0. I'm trying to do n, but it's fine. 0, base 0.
That's for the first one. That's for the first digit. So you have to write down for all 4 of them.
Yeah. Yeah, I have to write down for all of them. So conversion, then you have the base and then that. So you take that and that increments. 1, 2, 3. So kind of like that. So you take what we did basically, our number, our hexadecimal was 4F7A, 4F7A. We took the number and then we rotated it. So we did A7, or F, sorry, F7A. We rotated it and then we took that times and we multiplied it.
A7, A7, A, then the second one is 7.
A F
First
A7. Oh yeah. A7
F.
F4. Yeah. Okay. Then we convert it. So this is gonna equal to something. This is gonna equal to something. This is gonna equal to something. Use the conversion chart. We found A is 10. 7 is of course 7. F is 15. And then 4 is 4. Okay.
Actually, this is easy to remember. This particular one, A, B, C, D, E, F.
Oh yeah.
10, 11, 12, 13, 14,
Yeah,
15.
because you have 1, 2, 3, 4, 5, 6, 7, 8, 9, and it should stay the same. And then whenever you have 10, it goes A, 11 is B, 12 is C. Yeah. So, and then it goes up to E. So, okay, so now we have that translated. So now the actual math, we're going to do the actual math in the brackets. We're going to do actual math in the bracket. So you have 10 times, and you have 1 or 16 to the power of 1.
Power of 0.
Yeah. Oh, 0. And you take the same one, but you change this. 7. 16 base power is 1 now. It's hardcore math now. Then you have 15, then times 16 to the power of 2.
Which is 16. We can also say that to make
Yes.
it simplified.
Yeah, that's true. So 4, 3, right? And then after that you get the calculation. Three is of course math. 4 is sum.
You can actually dump it in our group chat.
This one?
Yeah.
Okay.
Rehana, just to make one point.
Yeah.
Before we rotate, the original number, hexadecimal point was 4F7A, right? So guess A, if you look at the, remember your last lecture, first you're with the 1, 2, 4, 8, 16. A basically is always hexadecimal start with 0, 1, 2, 3. That's why A is 0, 7 was 1, F 2 and 4, 3. Because we rotate that it comes to first comes in like a, first was A, 7, 4, A. Why A comes in 0? Because see, A is basically, if you look at from left to right, first one is A, so there's 0. 7, 1, F 2 and 4, 3, right? 16, 0, 16, 1, 16, 2, 16, 3. If you look at from left to right. But if you look at the, if you flip it out, if you rotate it, actually basically again first A is actually 0.
Yeah.
And then 7, 1, 0, 1, F2, 4, 3, because left to right.
Right.
That's the way you can always remember.
Yeah.
The
So
most to least significant digit, that's what we call it.
yes. See, the reason I flip it is because of the keeping the power straight, but you can do it other way too. Yeah.
I don't think this flip matters.
Yeah, it's easier way to remember. But if you get that, and then if you get the sum of the first number first, and then you take the sum of 2, or the map of 2, 3, and some 4, and then you get the total sum, and that's your binary or decimal conversion. Okay, so did that make sense? Okay. So now, going back to this, hexadecimal, binary, decimal numbering base. Okay, we got that. And an OR gate. Okay, good thing we took a break.
No.
Okay, so this is more of a little bit of an engineering side. So don't be overwhelmed by this. We're gonna walk very slowly and we're gonna go through it. So again, don't overthink it or why we do it. Just learn it first, then we'll decide why we do it. Okay. So you have actually, let's do it here. You have gates. Okay. You have AND gates and OR gates. You have NOR, or so we're going to learn what each of them do. Before we do that, we need to place very good attention to this right here, this chart right here, the A and B and the output. Okay. So if we go back, binary AND OR is going to give you, and we're going to know how to do this too, the OR gates, AND gates. But I'm going to show, whenever you actually do the binary logic, see if you do AND, if you have a 0 and a 0 on hand, where's the picture?
Always.
Yes. This is showing octal conversion and everything. So let's see. Let's go to the binary component. Okay, I'm going to go back and look at the picture. Okay, open image. Not letting me. There you go. Okay, so you have AND. So if you have a 0 and a 0 on your hand, then it's going to be 0. If you have a 0 and 1 on your hand, it's going to be 0. If you have a 1 and 0 on your hand, it's going to be 0. If you have a 1 and 1, it's going to be 1. But if you're looking at OR, it's going to be sort of reverse. So if you have a 0 and 0, 0, 0 and 1, 0 or 1, you have 1. 1 or 0, you have 1. 1 and 1 or 1, you have 1. So we're going to learn about this gate. So this is the binary logic, but then whenever engineers use it, they go ahead and turn it into this. So this is basically saying that whatever your output is, A or B, 0 or 0 or 0, 1 or 1, 0 or 1, 1, is going to be AB. And then you have NAND, so A and B, and then you have AND, but it's not AND, so that's going to be your line on the top. So A and B in engineering logic, whenever you have a slash on top of it or a bar on top of it, then it's not and. And then you have or, okay, A plus B, and you have nor, not A plus B. So it's a not. So looking at this, you have 0 and 0, and according to our chart here, 0 and 0 is going to be a 0. And then you have 0 and 1 is showing that it's 1. And you have 1 and 1 is going to give you a 1 as well. And then 1 and 0. But look at the or. You have 0, 0 is 0, 0, 1 is 1, 1, 1 is 1. What we just learned. It's just converted into graphics. Then you have this picture right here. Okay. Now, this is what the engineers actually use it. Circuits and everything. So you have this input. Okay. Think about it like this. You have two electrical system. Okay. You have input A and input B. And then input A, whatever it transfer into this. So this is OR, and or it's not an OR. I forgot what this was. It's not. Sorry, it's a not, and it's going into AND. So input A is going up here. It's becoming a not, and it's going to the AND. So if it was 1, it was going up here. Then it's going to become 0, and then it's going to come to this home. Then if you look at input B, let's say that it was 1, okay, it's going to go up here, but since there is no not on there, it's not going to flip, it's going to go as 1. Then they're going to do the 1 and 1 conversion. 1 and 1 is in this, in this AND field, and then whatever this result is going to go to the OR gate. Same thing on here. Input A, if it was 0, then it's going to go straight here. If input B is 1, it's going to go travel through here. It's going to become 0, and it's going to travel to here 0. Now we have 2 zeros in here. 2 zeros is going to go, 0. So it's going to go to the OR gate. And then whatever the result we got from here and whatever the result we got from the other end, we're going to do the OR, and that's going to be the output. That's basically the electrical system.
One.
One. Yeah, it depends on what your input is. It's going to be your output. Now, that's how the hardware is doing the electric circuits. The hardware is working as we are programming on the front. Again, do you need to know this for your everyday job? No. Probably want to know how it all works out. Now we know what computer does in the background. Sort of. It will not always add up 100% in your head, not completely. Till we go through the class, it will probably add up more and more. But for now, this is good enough, and it will be pieces, and you're going to be taking it from this class, taking it from this class, and you're going to see a whole picture. So right now you see a part of the picture, and that's okay. There's no need to freak out about that.
Can we comfortably say that all these tech folks that are working, that no one actually knows everything?
Nope.
Right?
Yeah, you're right.
And it's still okay.
And it's okay.
You can still make it.
Yeah. You just need to know how to do your portion of the job. See, we don't have to be Bill Gates. We don't have to be Mark Zuckerberg. But we just need to know how to do our job.
But to be honest, one thing I can shed a light is this question. Like when it comes to the design, you are basically your main job to break the designer any kind of law flow going on in his design, right? So if you have that particular conception in the design, you can pinpoint it. I think that you might have a way for how the coding.
Basic.
I think it's today, tomorrow, next week, right?
Basic is gonna be about three costs. Three costs, maybe 4.
So this weekend and next weekend.
No. Yeah, this weekend and next weekend. We might we might go over to the third week, because we have a HTML project. Usually we give it on Saturday, but then Sunday, no one can turn it on Sunday. but next Saturday it's turned in, but
Okay.
only half of it.
So this week is considered first week.
This week is considered
Okay.
first week, yeah. And yeah, there's a lot of boring stuff. It's gonna, next
Yeah,
class
it's
is
fine.
gonna be better.
Easier, you think?
Easier? Well, it depends. Either it clicks in your brain or it doesn't.
Okay.
Yeah. But these stuff, if you don't get it, it's okay.
Yeah. I
Like
don't
he
think
was
I'm gonna
saying,
use
no
it.
one is expert. No one is expert. And if you're expert in your job and you just know these things, a little bit of these things, that should be good enough.
If you
No.
work as a logic designer, this is what you're gonna need.
Yeah,
But
yeah.
I don't think
Engineers, they
Yeah.
probably, they have to go through the
these are
hundreds
logic
of
designers.
math problems like this to become an engineer. You are not going to be that engineer. You're not going to be that engineer. But yeah, our main goal is to just know it, touch base, but we don't have to be an expert in this.
Yeah. That's the computer science, the first class, the first week.
Yeah, computer organization. Yeah,
The first class.
yeah, it is. But it's something. I mean, we learned it. We have one whole class dedicated. We actually have two class dedicated to it. But what do we use it for?
Yeah.
If you don't go in that field, then you don't need it. If you do decide to do your master's for computer engineering or any type of other engineering, then you probably will need it. But for what I'm doing right now, I don't need to know this. Yeah. So, okay. So, any questions before we get done? Yeah, questions or no? No? Okay. So we'll send out a video today, and then we'll send out a little bit note what we covered. So those of you who are taking notes, please keep taking notes, but we'll send out our version of the notes and presentation as well. So if anything not clear, then you can ask me tomorrow, or we have a Wednesday class session that's open to anyone. Okay, you don't have to come in. We don't come in. You can come. You can join online. If you have any question, you can shout out the question Wednesday. But if enough people, no. So Wednesday we let you guys decide because we keep our schedule Wednesday and Thursday free. So one of the mentors keeps their schedules free. And then based on your guys' schedule, you guys are going to talk to each other and say that, oh, Thursday works better for me or Wednesday works better for me or Wednesday at 7 o'clock or 8 o'clock. And then after that, we just sit there for like 1 hour and 30 minutes. But if you guys don't show up, we'll be upset. Because you're going to be sitting there, so.
Oh, you mean coming here?
No, online.
Oh.
Yeah, we don't open up the, we don't open up.
You have some kind of sort of program. Any kind of places that you're going to put all the number of phone number that you're going to go and particular that you're going to keep your all the notes.
Yes, so we do have a student portal. Everyone has a student portal login here, but we're going to give that out about third week or so because there's a lot of students who are going to decide no to this class. So, but for now, we're sending it by email. But then eventually you're going to see all of them in a notes section is going to have all the notes, presentation, and presentation. And your exams too, over there. Yeah. So.
Okay, so you're going to email basically now.
For now, yeah. Till we have a contained class list, we're going to email.
So
Yeah.
by this week sometime you're saying?
Third week. So after HTML.
So
The
how
HTML.
long are you going to be in the whole, up to the last, how many weeks? Altogether 14 weeks, right? 16 weeks.
Altogether 4 months. So
16
weeks, yeah.
So you're just going to be up to the whole 16 weeks?
No.
Or up to maybe 10 weeks or how many weeks?
So me, I am going to do only, I'm going to do this classes, the CNS, and then database because I work more with database. And then AP is going to do the SDLC and then the business document, and Chaz is going to show the softwares, and then Enrico is going to take over the automation.
SDLC is very important.
Yeah, very important.
Yeah.
Yeah. So it teaches us like the basic process of how the company works right now, right? So.
What are you going to be covering tomorrow?
Tomorrow is going to be same thing, but we're going to be focusing more on Excel. By the way, that reminds me. Thank you for asking. Homeworks for you, set up Microsoft Outlook, and 5 things you did not know about Excel. So tomorrow we're going to learn about Excel, some tools. We're going to start HTML. We're gonna learn the definitions and stuff. So hopefully by next week you guys can make your own website.
So this is for tomorrow, right?
This is for tomorrow. So set up Outlook and 5 things you do not know about Excel. And Excel is really important, even like not for QA jobs. You're doing your budgeting or, handling financials is very important. So
are you guys gonna give it, because I actually, I'm not good in Excel.
yeah.
So are you guys gonna go through the Excel?
Yes, we're gonna go through it.
Is this tomorrow or next week?
Tomorrow.
We're gonna be expert on 14.
It's fine. It's simple.
Okay.
You're just adding, subtracting, equal sign. Yeah.
So this will be our tomorrow's thing?
Yeah. No. This is gonna be tomorrow's thing. The homework is for basically tomorrow. We're gonna go over Outlook and then Microsoft Excel and then HTML.
Okay.
Yeah.
After the HTML, then go to the database, SQL.
Database and stuff. And most people don't like that part, but it's my favorite.
Tomorrow is what time?
9 o'clock.
Yeah, thank you.
9.
The class will start at
9. Yeah. So 5 things you did not know about Excel. So if you already know it, if you're in an advanced position, then learn 5 new things.
Okay.
Yep. Okay. All right, guys. Thank you. Online student, do you guys have any questions for me?
From whom? What's the number? I forgot.
Okay, thank you guys for joining. You guys should expect an email from us. If you don't, reach out to us. It takes me about 2 hours to convert the video. So probably around 2 o'clock, 2 to 3. Yeah. We'll send a message on WhatsApp saying that, saying that we have sent it.
You already have
You may access code. Meeting. Just I mean, go to meeting.
And then, here. I have it. Yeah.
Go to meeting, they will ask me the one access code.
Let me look at here.
I'm not coming tomorrow, so hopefully you'll record the session.
Yeah, I will.
Because I have a lot of people coming around, so hopefully you'll have to record the site.
Yeah, no problem. I'll record it. This number right here.
Okay, what's the number?
168
Okay.
367
367
893.
893.
Yeah, that's
168 367 893.
Uh-huh.
Okay. In the network meeting, yeah?
Yes. So